We'll start with a song.
This is a song about a whale. No! This is a song about being happy. That's right. It's the happy, happy, joy, joy song. Happy, happy, joy, joy.
I can.
Happy, happy, joy, joy. 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 Happy, happy, joy, joy, joy. I don't think you're happy.
All right. I'm Aaron Hammer. That's my Twitter handle and my blog. I also tweet at Universe. That's a more work-friendly account. You don't get to hear my political views and occasional curses that I have on my personal one, so you can pick. I'm most known for my work on OAuth. I was on the original team that wrote OAuth 1. I was the lead author for OAuth 2. I'm also known for the guy who quit OAuth quite suddenly and with a lot of curse words to go along with that departure. And yesterday somebody found a way to break Facebook OAuth. So I was like, yes. My predictions are happening. All the artwork in this presentation was done by Chris Carrasco, who is a very talented cartoonist that has been working with me on a lot of those presentations. A little disclaimer. If you Google me, you'll find that I tend to curse a lot in my presentations. I have two 8-year-olds at home, and I don't get to use that language at home a lot, and I work from home, so I have to keep my language clean. So when I go out of the house, I tend to let it all out. This time I'll be more work-friendly. All the quotes in the presentation were approved by Nickelodeon for 8-year-olds. So if you feel offended by them, it's something with you because they've all been approved. Yeah, it was in the 90s, but still. So I'll talk about Hapi, which is the Node.js framework that we've been building at Walmart Labs. A little background on it. 2.5 years ago, I was working at Yahoo. I was working on a project called Sled, which was a little startup-y collaborative list-making tool. I was doing it, just me and one more guy was doing the front-end part of it. And about a year, that's when I fell in love with Node. It was really, it was just like suddenly I'm enjoying my work. I feel productive in the language. I love JavaScript with all its good and bad parts. And Node was just such a productive environment. After coming from a whole different variety of frameworks. And so I was doing it for a year, and then when my boss quit, and I realized that my project is probably going to get discontinued very shortly after, I started looking for a new job, and what I really want to do is just keep hacking on Node. So when I went to companies to interview, I was like, yeah, there's all this OAuth stuff, but I really want to hack on Node. And then when I talked to Ben and Dion at Walmart, they said, well, it's exactly what we want to do. We have an old web services layer. We need to redo it. And Node was one of the technologies we were looking at. So that sounds like a good fit. So when I joined in, the first thing I did is, before I left Yahoo open sourced the entire Sled project. It was open sourced as PostMile. You have the GitHub address right there. So you can see it. And at the time, this was the biggest Node-based open source project anybody did, like a product, not like a framework or a module. And so we took all the good parts that we've been building on top of Express from Sled, and that was the first version of Hapi. It was very, very basic, but that was the foundation. A little bit of what we do. I work at Walmart on the mobile team, and we do all the mobile apps that people use and the mobile web. If it's we have an iPhone, iPad, Android apps, we have a mobile website. And we also build sites for different countries. So we do the Asda. Asda is one of the biggest groceries in the UK. It's owned by Walmart. We just started doing the Sam's Club. Sam's Club also owned by Walmart. It's a big company. And we're working on other regions, other countries as well. So we have all those apps, and those apps have to talk to a bunch of APIs. And those APIs come from stores for iLocation, store availability, store price, because our prices are different for each store. And we have different inventory in different stores based on local preferences. Walmart is big about customizing their stores for the local market. We deal with the e-commerce site. That's the actual Walmart.com. So they have their inventory, their fulfillment centers, deliveries. And then we do a lot of third-party. So if you do photos and reviews, those are all third-party APIs that we use. And those APIs are anywhere from okay to god-awful. Some of the better ones are SOAP. And I mean, a lot of those are based. Some of those are running on AS400. Some of them are running on Java Stack from 18 years ago. And it's going to take a long time to move them forward. But you don't want to have that kind of legacy stuff in your apps, especially if you're writing, a mobile web, one-page app. You don't want to interact with those APIs. You want it clean. You want all the payload to be JSON. You want a simple authentication layer. You want smart caching. You want to have batching functionality, because you don't want to expose the service abstraction to the app. You want the app to be able to make one login call that will get you logged in, profile, last items you looked at, your favorite searches and stuff like that. And because we're a mobile team, everything we do is on a crappy network. So we really have to optimize our work for that. So we really need this mobile services server that's in some way it's a glorified proxy. It's just sitting there between the actual services and then the apps, and it's doing the conversion, normalization, cleanup, and so on for us. And when we looked at this, we said, Node is perfect for this, because Node is the sweet spot for Node is heavy on the network, light on the processing, kind of like passing through a lot of streaming functionality. And so we start playing with that. Ben likes to say that I joined in, and after 2 weeks we had a first big architecture meeting to decide what technology to use for this new framework that we're building. And I said, well, if you look at my employment letter, I was promised Node. So pick whatever you want, but it's going to be Node. Now, I'm going to say some stuff. I'm critical about some of the other frameworks, of course, because we decided to build our own. And I want to make 2 points. One is people have done an amazing job. Other people have built their own frameworks. And whatever criticism I have about Express or Connect or Director or Restify or whatever other frameworks are available, it's not a personal opinion, and it's not a personal offense about the people who wrote it. I have great respect for the Nojitsu guys and TJ and all the guys who did this amazing job and really sustained the Node community in the past few years, and really helped us learn how to use this technology. But at the same time, I feel that a lot of them are on the wrong path in terms of how they design their frameworks, and so that was one of the reasons we decided to do it differently. And we did try. I mean, we started with Express. That was our first. So Happy was built on top of Express in the beginning. And then when we reached the limitation of Express, we ripped Express out, we put Director in. And we went with that for a few months, and we tried that. And at some point, we were like, you know what, we need to control the whole stack. We need to have our own router and our own, and basically end-to-end, because we kept hitting the limitation of those frameworks, and we kept finding myself hacking around them, and we kind of felt like they're already hacking around Node to begin with. So the pattern you see most, how many of you have played with Node? Oh, awesome. So you're all familiar with this pattern, the request response next. And this was the connect pattern that team came up with, back when Node was 0.0 something, and the idea is that all you do is you chain functions. So one, and it's they're calling it middleware, but I don't like the term middleware. It's just a chain of functions. So you have a route, you have some kind of request path, and then you start matching any function that will match the reg expression for that path. You'll execute in order. Of course, that means that the order you call them matters. If you've ever done a big app on Express, you've experienced the fact that if the body parser comes before the cookie parser or the passport module, if you don't load them in the exact order, they don't have the expectations are not met in terms of what should be there. To me, like one of the annoying things when I talk to newcomers to Node is that they get a request object and it's like, where's the body parameter? I'm not seeing the body parameter, and it's like, well, the body is not part of Node; it's part of Express, and you have to. You get a read stream that you actually have to read it and get it before it's available to you. And by default, everybody's installing it. But what if you're doing a major upload? Like if you have a file server, you don't want to go and read everything into memory and then write the file. You want to stream it directly from the socket into the file or somewhere else. But that's not the default behavior, and so. The other thing is because you're passing the native node object, the request response object, you're now adding your own keys to those objects. And if node will change in the future, you might have conflicts. It's just a messy way. I mean, I know it's JavaScript, so let's not pretend it's not. It's something else. It's not. This is not a language that protects you from doing stupid things. But at the same time, to me that always felt wrong. So we decided we're going to have our own object. We keep access to the original raw objects. Again, I'm not pretending I'm not doing JavaScript, so I'm not going to, like put underscore before it and then pretend, oh, it's not there anymore. Just don't use it. And the reality is that you're going to use modules with hapi that will require access to those objects, and I don't need you to start writing wrappers over everything we give you, so it'll work with the ecosystem. A lot of undocumented expectation, so it doesn't say anywhere that this middleware it requires this middleware and so on. It's more of like you try it and you go to the mailing list and you say it's not working. And it's like, oh, did you load those things up before? And then the bottom line for me was this mixture of HTTP and business logic is not healthy. The fact that there is no separation between where your business logic is, where your app itself, and where Express is or Director is or Node is. And I'm not a purist. If you need to go and set a custom HTTP header within your business logic because you have to do it, then do it. That's fine. But you shouldn't need to directly interact with cookies in your business logic. You should interact with higher level objects. And so to have the cleaner separation, so your business logic handler is not basically getting raw node objects as its input. And the first question I asked myself when looking to design your system is really coming from other big companies before, and I've seen what happens. You have this brand new system and it's great now, but then 2 years down the road, everybody hates it. And the people who created it are no longer there. They moved to something else. Now you're in maintenance mode, and you really kind of have to ask yourself, like, are you enjoying what you're doing on this framework, or are you just dying to replace it with another brand new framework? And a lot of that comes from, there's no clean separation between the business logic and the framework. You need to have expert insight into the framework itself. So if you're using Express, you really have to go and look at the code to see what it's doing. One of my favorite gotchas in Express is that it will not limit the payload size. So if you have the body parser loaded, it will basically read into memory as long as the client is transmitting. There's another middleware that will limit the size. But if you don't know that, if you didn't look at the code and saw what it's doing, and I bet almost 90% of Express deployment out there, if you just connect to them and start sending payload, you'll bring the server down. You'll just get them out of memory. And I don't want that. I don't want the people who are writing business logic to have to understand those things. That should be declarative up front. So we started looking at building hapi, and the first principle we decided on was configuration over code. If you look at the typical Node server, there's a lot of code involved. Like you want to add a route, you're calling a function. You want to define a session, you're calling a function. You want to add authentication, you're calling a function. Everything is a function call. And all of the configuration itself takes functions as the configuration. And we try to move to an environment where we do as much as we can within code. We're not preventing you from within configuration. you can still write as much code as you want, but if you don't want to, we're giving you a tool that will let you express all those things with configuration, including input validation, output validation, schema. And the benefit of doing it that way is, first, you get reflection, which is really nice, because now all your endpoints, the code itself is the documentation for the endpoint, and we can take that reflection and we can turn it into pretty HTML. We can even automatically produce stubs, so we can take our API descriptions and turn it into Java stubs, so our Android developers can just put that into the app. So every time we have an API change, they don't have to go and change all their classes to serialize all the JSON they're getting. The MWeb guys, they don't care about any of this stuff because they just talk in JSON. But the Java guys do, or the Objective-C guys do care about that. When you're working with configuration, you can validate it because you can look for bad keys, bad values. It's much easier than validating code. So there's less errors, more consistent, and it's a lot more reusable because cutting testing code, we all know how well that ends up. As opposed to cutting and pasting configuration, that typically works pretty well. We came up with this wish list of, that's like a year and a half ago, like what do we want to have in the framework? Plugins, a big one. We want to make sure that not every feature you want, we have to change the framework itself to give it to you. Caching, different levels of caching of the inputs, caching of the processing, caching of the outputs. Authentication. Originally, Happy was focused on APIs, and so we baked in some basic authentication that are API-centric. Recently, we've added a little more in the cookie authentication, and now we're actually working with Jared Henson, who is authoring the Passport framework to make it work with Happy. So that's going to come in the next few days. A lot of validation. If you ever written business logic code, you know how much time you're spending on just validating inputs. You're getting, if it's query parameters or payload or whatever it is, you're spending so much time. And then if you try to do a really restful system, we've all been there where you have this endpoint, and let's say it's a list item. And you can either update the list item or you want to move it somewhere, you want to change its position. And in your architecture, it's all that one resource identifier. And so now you're adding that if you post it with a payload, it will change the item. But if you post it with a query parameter that says position, it will move it in the list. So we all came up with those, you find those edge cases of REST. And now you have to come with those validation rules to say, if it has this parameter, it cannot have a payload, and if it has a payload, it can have this parameter. And if you try to do that in Node, it's pretty painful because if there's any callbacks involved, now you're writing sub-functions just to deal with all the flow of the callbacks, because it's not linear code, because it's all callback based. Utilities, a bunch of easy things, serving static content, storing directories, proxying to another endpoint. That's a typical use case where you want to just, hey, this particular endpoint, just go right there. And then views support. We're not building a presentation layer. We're not building a framework that will work as is for front-end development. That's not the goal. But we are supporting templating and to the extent that Express or other frameworks support that functionality. So you can build a website on it with no problem. So if you look at that list, and if you've been involved in the Node community, you're starting to scratch your head and saying, like, this doesn't sound like Node. Node is all about tiny, tiny little modules that are like half a function long. And this sounds like you're building this gigantic monolithic monstrosity. If you look at Express, it's like a couple hundred lines of code. That's it. That's all that's there. And I'm describing something that sounds like I'm building this gigantic environment. And so we've developed this expansion contraction pattern of how we work, where basically everything goes into core, and it's undocumented. So we're adding a bunch of features to core, and we're trying it ourselves, and we build products with it. And then if we feel that it's really, the integration is really critical there, for example, caching, then it stays in core. But if we feel that it's not so core worthy, for example, the documentation generation, or a monitoring plugin, or debug, we have a debug console that you can connect to your server and see everything that's going on using WebSocket in real time. So those are not core features, and so those get moved out. So we have this pattern where as opposed to most other frameworks where nothing goes in until it's proven, we put it in first because we want to get the integrated experience. And after we get the integrated experience, we feel that it's not really adding value, we put it out. But if the integrated experience is significantly superior, then we leave it in. All right, so let's look at some more details. So we have a bunch of modules. The code name for the project is Blamo. If you know your Ren and Stimpy, you know log. And but in terms of the actual framework, where the marketing is focused on hapi. That's the core framework, and not all the other 50 or so modules we have at this point. A few bragging rights. I love this slide, since I get to show off. We have 100% code coverage. 100%. Every once in a while, when we find limits in the code coverage, because sometimes if you organize your statement in a certain way, or if you compound your if statements, you have ORs, you don't always hit all the ORs conditions. So we're actually trying to improve that with the coverage tools to better highlight what we're testing. But with 100%, and I can tell you, a lot of people look at me and it's like, that's not that important. For every percent we got from 85 to 100, for every 1% of coverage, we found at least one bug. And these are not typos, actual bugs. We forgot to set this header, or this code will not run. It's just there's no way that this will execute. And as you know, all those bugs are going to be in the error handling areas, right? Because that's the part we rarely test, and that's the part that's hard to simulate. And there are places where we had to go through. We have to game the system to get 100%. If you were trying to test for uncaught exception handling, well, you can't. Because if you have a test framework, then it's not going to be uncaught. So some places we had to game the system to get that coverage, but in most places it was a valuable experience. We have a full-time team working on it. Right now we have 3 full-time engineers working just on hapi, which nobody else can say. And that's great in terms of open source. We're betting big on this framework for Walmart, and so you can trust that this is not something that I'm into it right now, and then in a month I'm going to move to something else. The organization has basically made an investment in it. It's designed for Walmart scale, and I've said design and not at Walmart scale because that will take a while, and we're rolling it out now. And as we roll it out, we'll learn and we'll improve it. I'm sure there's like all Node programs, I'm sure there's some memory leaks in there and other goodies that Node is notorious for. But this has to drive our entire mobile e-commerce, and there's a chance that it will also drive more than just the mobile e-commerce at Walmart. So we take it seriously. It's been open source from day one. We believe that even when you're not ready for prime time, you should do it in the open. So you can go back and you can see every embarrassing mistake we've made, and you can see the entire project from the very first line of code in there. And we're committed to community leadership. Ultimately, Walmart is not in the business of maintaining a Node framework. That's not what this company does. And so we're hoping that more people will use it, and as we see the community building around it, we want to expand and involve people from other organizations or just open source advocates and really build a more open governance around it. All right, let's look at some code. All right, so just starting with a typical require. We capitalize our requires as well as the classes you have to new. That's our internal style. Some people hate it, some people like it. That's one of the few things I refuse to change in my examples is that particular style. You create a server on port 8000, and then here's a little business logic. So it's a simple handler that takes a request and replies with this object named Steve. We add a route. So we create a route. We have a method, path, and a handler. So far, pretty obvious. And then we start the server. So this is like our kind of hello world example of building hapi. We can make it a little more interesting. Let's say we want to add some caching to this. So we're going to define a cache for the server. We're going to use Redis, and this will just use the Redis engine with default settings. So it will look for whatever the default port and IP address are. And then if we want to add the caching to the actual route, because right now we just enabled it, we're not caching anything yet. So because of screen real estate, I'll focus on this little blob here. I'll just move it up. And then we're going to add a config wrapper. And then here's the caching. And this caching configuration basically is saying we're using server-side caching, and everything will expire in 5 minutes. And that's it. And from now on, every request comes in. If we have it in the cache, we'll serve it from the cache. If you add plus client, you'll also set the cache control header for the client. If you remove the server and just do client, then now you have your policy for your caching. And so we find this to be really nice because we don't have to manage those separately. It's one policy. And of course, because it's configuration, it's automatically documented. This is a little neat feature we have where we have staleness. So we can say this thing expires in 5 minutes. It's stale in 4 minutes. So after 4 minutes, before you serve the stale object, go try to get it again. If it takes more than 200 milliseconds to get it, serve the stale one, and when the new one comes in, replace it. So the next guy, and it kind of gives you a self-warming cache. The cache constantly keeps itself warm. Let's look at a different example. Here's a validation. So we have this RPC style endpoint here, user, and it can take a query ID that's a number. And we want to make it more specific, so now we're saying it has to be a minimum of 100, and it's a required field. And what you're seeing there, that types statement, that's coming from another module we have called Joy. And that's basically, we looked at different schema languages, JSON schema and different, and we didn't like any of them. They're either not expressive enough or too complicated. And we looked for something that's a little more intuitive and kind of like more, not quite natural language, but that can read almost like one. And we came up with this, so it's not, it does have function calls in it, but it gets converted into just a JSON configuration internally. And you can use that validation module independently of hapi. You can just use it as is. It's great. And we keep making it better and better. We're working on the feature now that if you give it an object and the validation rules, and it will give it back to you with colors it will kind of print it out and will color red everything that is not right on. So if you're loading a configuration file for your system and it's not right, it will spit out and show exactly all the points where it's wrong, and in the bottom it will tell you this should be a number, not a string, and so on. Now, we're going to give you the option here to use the username. So now we have an RPC input that takes an ID or a username, and the username is a string, alphanumeric, minimum 3 characters, maximum 20 characters. But of course, we don't want both. So now we're saying one has to be without the other. So it's this kind of expressiveness that we're trying to go for. And this is readable. I mean, this is, it's just, if you can read English, you can read this. And then everybody who needs to understand what the endpoint does can just come here and see it. Let's look at something a little different. Here we have a more restful endpoint. So we have the parameterized path, so you put a D in there. I know other frameworks like to put colon in front of their parameters, but colon is a perfectly legitimate URI character. So we decided to go with a more standard approach and use curly brackets. And then we have the handler, and you can see the handler. It's doing a very simple database lookup, and then it's using that request params ID to look up the item. And if that bugged you before, now we also have error handling in there, so we'll make sure that we didn't get an error. And if you look at this little piece of code here, this is 4 lines, so I'm not going to pretend it's very complicated. But if you think about typical, loading your prerequisite, loading, you have a business logic that needs to, get the user record and permissions and some profile information. This will get big. So you're going to go and you're going to write a helper function, right? That's typical procedural design. So here I have this user function, and I'm not doing anything special here. But what I can do with hapi is I can actually register that as a helper for the server. And now it's available as just add the function onto the server, and so now it's namespaced. And then this is how I call it. I just go server helpers user, and I give that information, and I get it back. But what I can do now is everything I can do on the route in terms of caching and other configuration, I can apply here. Input validation and so on. So I can actually have all those cool facilities I have for route handling on the functions. And so now I have it cached for 2 seconds. So I might not want to cache the output because let's say the output is customized for the user, but I might want to cache the inputs. And so that lets me do that. So if I go back to my example here, then I replace this whole code with this little server. And again, if there was more code in there, it would be more impressive. But it's a short example for because of the real estate on the screen. But if you look at this, you can think of it in typical systems. Half of your endpoints will require a user record to do anything, right? Like you're going to be looking at this record app almost for every round trip. And so really what we've done is we're allowing you to define prerequisites. So now you can say, here's my business logic. My business logic is expecting to get the user record before anything is even called. And if it's not there, don't even call it. Just give an error. Don't waste my time with it. And now you have this business logic that is really, really simple because it will only get called if the inputs are there. And so, and if you look at the method, it's a string. It's a shorthand feature we have that if your prerequisite is a registered helper, then you can just use this notation. But if you want to do anything other than that, you can just put a function there. And this doesn't call eval or anything like that. It's just parsing it. And it's a very, very restrictive syntax. So if you need anything more than the super restrictive syntax we're allowing you to do, you're going to have to write a function that wraps whatever helper you're doing. And if you see, we're basically only letting you access properties of the request in terms of what you're passing in. You can't pass anything else. So if you need to pass a constant or anything like that, you have to write a wrapper. And then, of course, if you're going to have multiple prerequisites, you might want to decide how you're going to run them. If it's database lookups, you want to do them in parallel. If it's something you have to process one or the other, you're going to do it in serial. It defaults to serial, and parallel, you can override it. And the reason why we have this config layer, if you're looking at the route, has method, path, and config, because we can do stuff like that. So now you can have one file that have your routing table with all your paths and methods, but then you can actually move all the actual configuration to a different file. And that's why we have that level there. This is a simple example of serving a directory. You can basically do it this way. And the thing we have done differently from everybody else is that we decide that we don't want to do a catch-all, which is kind of how all the other static server work. You basically, you look through all the routes, and if you can't find the route, then you're looking at the file system. And that kind of bugged me, that approach. So what we're doing, we're mounting a directory into a path. And we have a bunch of tools to map it, but what you can do is, in this case, we're only letting you go one level deep, so any files within the images, within the public images directory. If there are subdirectories, you can't access them because we don't allow you, because this match will only match one segment. If you want to match anything, then now you can have this syntax where it's a wildcard, so it will match anything after images. If you want to limit it to 3 level deep, then you can say only 3 level deep. But this is kind of like and of course, everything you can do with paths in terms of the parameters and the wildcards available anywhere else. It's not just limited for this. Here's a simple hello world example. So here's where we're just replying with a string. If you want to reply, we want to customize the reply to something more specific, you can use that. So you can say, this is the content type. Here's an override TTL. So you can, if you have a caching policy, but you want to, for some reason, this particular answer, you want to give it a different expiration, you can do that, and then you can send it. Here's an example using streams. So node streams are really one of the most important features that the framework has. And it's like everybody who's using Express, it's kind of like a default behavior. It's like, no, Express will do this for me and I'll get a nice object. But that's really wasteful, especially if you don't need to parse it. If you're just passing it through, not only you're saving it to memory, you're doing JSON parse on it after that, and then only back to serialize it into a string and then send it out on the wire. We can, so this is a very simple echo example. So in the config there, because this is a post, by default, we're going to parse the payload for you. But we're telling Happy, don't parse anything for me. I'm going to stream it. So just leave it alone. What will happen is we'll get the node incoming request, and we'll pause it immediately. And so you can do whatever you want, and then when the time comes, you can pipe it into whatever you want. So if you see what I'm doing here is I'm actually responding back with the raw request string that came in. So if you run this code, it will, anything you send to hello, you'll get back as a response. So that's an entire echo example. This is one of my favorite features, and it took quite a lot of like hackish efforts to get it to work. But basically, if you ever wrote a web like any web APIs or services, the debugging it is a pain. I mean, you can do unit testing as much as you want, but to actually do full integration testing typically involves bringing up a server and connecting to it from the outside and sending it requests. Which is okay, but it's not great, especially if you start dealing with ports allocation and you're running it on like Travis and stuff like that, and the port is taken and the test fail, and you have to go to the. We've all played the game. You can see, like, if some of the projects in their commits, you see moving to port 8852, 8853, 8850, like until they find a port that's available, and then 2 weeks later they have to change it to test again because it's failing again. So we have this inject function that will basically simulate an entire request going through the server. It works with streams, it works with third parties, it works with anything you want, and it's great because then in our test we use a lot. So all our integration testing, we use that. We rarely start the server. Only when we do like more advanced tests that we actually want to go to the socket, we don't. And this is not just for testing. We have implemented a batch functionality on top of it. So if you think of, you have an API, you have a bunch of APIs, and when somebody logs in, let's say the first thing you do is you get the last item they looked at, and then you want to get the item description for that. So it's 2 requests. If you're implementing it from the client side, now you have a blocking request. You first have to get the first response, find the ID, make the second response. On a mobile phone, it's very expensive. So we want to have some batch functionality. And this is not something that we've created, inventive. Like everybody who has an API has some kind of batching functionality built in there. This gets complicated once you have authentication, especially if you have like OAuth 1 authentication, which requires some signatures. And if security folks in the room, because you know what you have to do and you know how disgusting it is, you have to get the signed request from the client, look up their secret in the database, and then make requests to yourself signed by you as if it was the client. Because that's the only way to actually pass it back into your system. This functionality was actually the main reason why we moved away from Express and used Director for a while, because there was no way of implementing this in Express without making an actual socket request in to the server. And so this is really cool functionality. This is hot off the presses. This was released yesterday. It's our new plugin architecture. It's still excuse me. It's still undocumented. Which means it's semi-experimental, but we've been using it in production for a little bit. It's a bunch of stuff we did internally to manage our deployment architecture, and at some point, mostly because I don't want to work in the enterprise GitHub, I just like working on the public GitHub. I'm looking for excuses to open source everything, so if it's open source, I don't have to log to the VPN. And so all of the functionality has moved on to the point where you'll see at the end how little code we have to write for putting our server together. So this will be if you want to write a hapi plugin, this is really all you have to do. Is you have to export a register function. It takes a server object, options for that plugin, and a next function. You have to call next when you're done. Within this, you can do 4 things. You can add routes. You can add cookie definitions. So for example, we have native support that you can define a JSON cookie, and we'll automatically serialize it in and out of the cookie. You can even do encrypted and signed cookies and so on. So you can define those states. We have helper functions. You've seen it before. You can register those, and you can listen on events. So all the events we expose, we have response, tail. We have a bunch of events we emit for each request. The good news here is that there's not going to be any conflict with any of these. Hapi, the router will not allow you to add conflicting routes. And so we worked really hard to make the router deterministic so that no matter what order you're adding routes in, they'll always end up in the same order. So the timing doesn't matter. If you have routes that obviously conflict, if they're identical, or if they have /a/parameter and /a/parameter name something else, we're going to catch that. And then if we have conflicts that are because once you have parameters, you're going to end up in conflicts. It's just a question of how you manage them. So if you think of if you have /a parameter or parameter /a, both will match AA. So we came up with rules of how we're deciding which one comes first. And so it's from the most specific to the least specific. That's how we're going to match them. And sometimes we just had to have an opinion because it's kind of, in that example, for example, like, they're both as specific. It's just how you build your algorithm. So this is really good because now you can write plugins that are going to be completely safe. There's no way this plugin can screw up with your system because all they can do is just add routes, add state, add the helper, and listen to events. And they can't really screw things up. Yes, it's JavaScript. So if they really want, they can screw anything. But within reason, they can't really screw things up. And hapi will throw if there's a conflict there. So you'll know right away if something's bad. And if you want to actually use this as a plugin, you publish it, and then from your server, you just call server plugin, and you require that example. Let's say this register function is published as a module called example. You register it, and that's it. It will do anything it needs to do to your server. We can also send it the options, but then there's a point where you need to extend in a somewhat less safe, obvious manner. So we give you 3 extension points, 3 hooks where you can modify the functionality. We give you 1 hook on request. So whenever a request comes in, before the router even looks at it, we give you a peek at it. So that allows you to do, for example, mode rewrite. You can change the URI, and then the router will write it differently based on what you do. And we use that a lot because right now we have a restful API that's all /m/j and then a bunch of p1, p2, p5 parameters. But because it's JSON and not SOAP, then they decided to call it restful. Yeah, been there? So we can't really use the cool hapi features of configuring routes because the switch is on parameters, not on the path. And we don't want to write a router that's based on query parameter because that's just awful. So what we do is whenever a request comes into /m/j, we rewrite it to an actual path, and then it goes right back in, and then we have those endpoints defined. So that way we don't have to change the clients, and we don't have to go and add query-based routing functionality to the server. So it's a really convenient hook. Then we have on pre-handler and on post-handler. So request comes in on request. We do all the payload processing, all the schema validation, input validation, any authentication that you want, like all that comes in. Then we call the on pre-handler, then we call the handler, post-handler, and then we send it out. So we're giving you those 3 hooks where you can extend functionality. The thing about those hooks is sometimes in their order will matter. But in general, they can also screw things up because you're kind of giving raw access to everything. It's kind of like bypassing the hapi logic. But it's necessary. So what we've done is we said, if you're installing a plugin, if it's a third-party plugin, by default, we're only going to give it the permission to do route, state, helper, and events. But it might need extension. So you need to explicitly allow it to do that. So that's the allow statement there. And that's all you have to do. And if you want to allow it, that's fine. But at least you're being explicit about it so that when you're loading a plugin that will not work without this permission, you know what you're doing. And you might, if you're working for a company that is relying on this server, you're going to go look at the source code and see what are they doing exactly that they need extensibility like that. And then you can look and see. We're trying to solve some kind of dependencies because sometimes you have one plugin that depends on another plugin and you want to have, in the extensibility area, you want to have some kind of order into it. But it can get so complicated so fast that we're trying to hold off on that functionality of prioritizing extensions until we have some real-world use cases and we can really understand what we need and what we want to do. Because it can get so complicated so fast and then nobody will ever use it. Or it will go back to the same problem as it's as good as not having it because nobody can ever figure out how to use it and stuff just doesn't work. So this is a new, another new functionality we have. In our environment, we have APIs that require HTTP and APIs that require HTTPS. We also have an admin channel that is not open to the outside world. So every server instance will bring up 3 HTTP listeners, and then the load balancers and stuff like that will make sure to route it to the right one. So you can do everything over HTTPS, but you can't check out over HTTP. So we need to work with basically what we call server packs. And we don't want to go and individually configure all those. So here's an example where we have an HTTP server and an admin interface, both living within the same process. So we're going to create those 2 servers. Now create a hapi pack, and we add those 2 into the pack. And when we add them to the pack, we give them a name, and we put labels on them. And then this is how we, the same thing I did before when I registered the plugin to the server. So I did server plugin. Here you just do plugin, and then you do the same syntax, allow, require, and you register it. And if we look at an example plugin in there, let's pretend that this export is in a different module. Here's what we did before. We had server route. And what we're going to change is just changing the variable name. So now it's a pack, it's not a server. It's the same exact interface. We don't really care what you do. If it's one server or multiple servers, the interface works the same. It will just register that route to all of them. But what you can do now is you can select. So I only want to add this route to the API server. And I want to add this cookie definition to all the web servers. And so now it allows you to apply. So you can write, this will not be very useful in a public plugin, but in a business plugin, in your own private plugin, this is great. Because now, for example, we have a taxonomy plugin that has all the categories, apparel, electronics, groceries, and so on. And it's a big tree that the client load. And we also have an admin interface, so we can like sometimes we just there's a promotion and we need to push in a new promotion, winter clothing. So we have an HTTP interface into that plugin that you can make changes, and so we have two interfaces in there. We don't want to have to somehow manually do them separately. It's one plugin. Like if you have this taxonomy API, you need the admin features to go with it at the same server, same versions, and all that stuff. So this way, in our plugin, we say add all these endpoints to the actual API servers and add all these endpoints to the admin servers, and so it's all in one place. So that's what this one is doing. And if you do multiple selects, so within each select is an OR statement, and if you put multiple selects, it's an AND statement. So you can kind of like pick the exact one you want. You can also select by name if you want. So if you do select name, you can select the name server as well. So if you're looking at all this code, we looked at it, and so we had our first server for the US, and then Sam's Club came in, so we built another server like that for Sam's Club, and then Asda came in, we built another one of those for Asda. And all of them are using the same plugins, but because they're using different plugins or different configuration, we had to start, sometimes they'll only have 2 servers or 3 servers inside. But it was bugging us because how are we maintaining all these executables, right? Because each one of these, because it's a server. I mean, you have to have a node executable that you're running that is loading all those plugins. So we were like, okay, can we just do this instead? And this is JSON, right? This is exactly the same thing I just showed you. It's exactly the same. Here I have my servers there and the ports and their configuration, the labels. I have my plugins with whatever options they have, and I have my permissions. And so we created this functionality, and then we have this composer. You give the JSON to the composer, and it will create the server pack for you. So it's neat. You can just now you moved away from having all that custom code per executable to just having config file. Of course, you can take it to the next level, and now for our actual deployment, we only have 2 files. We have a package JSON that includes all the dependencies for NPM of the plugins we use, and we use private Git. So I don't know if you know, but from within package JSON, you can put directly to a Git address, and it will do it the same way that if it came from the database. So we point to all those, and that's where we control the versions. So if you want to change the version of a plugin, you just change the package JSON, and you give it to QA, and they'll test it, and you give it to ops, and they'll deploy it. And then we have this config JSON, which is the JSON I just showed you. That actually has what server to install and how to load them in. And then we do NPM install, and we run the happy command line binary, and that's it. And if you just do that, you now have created your server, loaded all the plugins, loaded the configuration, and there's no executable. So in a enterprise environment, this is great because now you're focused on writing plugins. It makes it so much easier to distribute it. There's nobody controlled that one server. If you want to switch on your own local environment, you want to play around with the versions, just go and change the package JSON that you have and do npm install, and we'll grab it from whatever it's the dev Git or the QA Git or the production environment. And again, how you deploy to production is depending on your policies. You might do some kind of shrink wrap or a tarball or whatever it is. Once it's actually ready to deployment, or you can run NPM install on your production machine, on your staging environment, if that's what you do. That's it for code. The overall effort that we have in Walmart Lab is called Blammo. We're trying to keep this GitHub page updated because at this point we have so many modules that we can't even remember all the different modules we have. And if something is not showing up on this page, it's mostly because we haven't got the cartoonist to create an awesome new logo in, or I'm not happy with the logo yet, so I don't want to put it on the big page. It's important. It's really important, you know. Have pretty pictures, because you'll never use a plugin that have an ugly logo. You know that, right? No logo or really nice one, but bad one, no. So you can go to that page and we'll link you to all the other one, including Happy, which is the first one there. There's some cool stuff we're working on, like a very simple XML to JSON converter that, if you have old APIs, you're going to need somewhere. It's using XPath, so it's pretty fast. We have the monitoring plugin, a cache plugin, the Joy model I mentioned before. We have one called Flood, which allows you to mock up a server and then benchmark it from the outside. And we use that between each version of Happy to make sure we are still at the same performance we were before. So it's a very, we actually have to, there's a blog post coming about that, so because we think it's a useful tool to have. And that's my talk for today. Any questions?